Imagine a day 66 million years ago. Lush jungles cover the earth, teeming with life. The air is thick with the scent of ancient flora, and the sounds of exotic creatures echo through the dense foliage. Dinosaurs, giants of their time, roam freely. These magnificent creatures dominate the land, from the towering Brachiosaurus to the fearsome Tyrannosaurus rex. They are the undisputed rulers of this prehistoric world. The planet seems eternal, unchanging. For millions of years this has been the way of life. The cycles of nature continue uninterrupted and the dinosaurs thrive in their prime. But in the vastness of space, a mountain-sized rock hurtles towards Earth at incredible speed. This celestial object, traveling at tens of thousands of miles per hour, is on a collision course with our planet. This is no ordinary rock, it's an asteroid, a leftover from the solar system's formation. Composed of metal and rock, it has wandered the cosmos for eons, a silent harbinger of doom. The asteroid slams into Earth with the force of 1 billion atomic bombs. The impact site, near what is now the Yucatan Peninsula, becomes ground zero for one of the most cataclysmic events in Earth's history. The impact unleashes unimaginable destruction. Earthquakes rip across continents, shaking the very foundations of the planet. The ground splits open, swallowing everything in its path. Tsunamis taller than mountains engulf coastlines. These colossal waves surge inland, obliterating everything in their wake and reshaping the geography of the Earth. The air itself ignites, sparking wildfires that rage across the globe. Forests that stood for millions of years are reduced to ashes in a matter of hours. Dust and debris choke the atmosphere, blotting out the sun. The once vibrant skies turn dark and foreboding, casting a shadow over the entire planet. Darkness descends upon the Earth. The temperature plummets and the world is plunged into a frigid gloom. The lack of sunlight disrupts the delicate balance of life. The planet plunges into a long, cold winter. This nuclear winter lasts for years, decimating plant life and causing a collapse in the food chain. The dinosaurs, once the kings of the Earth, struggle to survive in this new, harsh reality. This catastrophic event, the Chelyabinsk impact, marks the end of the dinosaurs' reign. Their extinction paves the way for the rise of mammals and eventually, humans. The world as it was known is forever changed. But the story doesn't end there. The impact serves as a chilling reminder of the fragility of life on Earth and the ever-present dangers lurking in the cosmos. The impact serves as a chilling reminder. The cosmos, while beautiful, can also be deadly. It is a testament to the power and unpredictability of the universe. We live in a cosmic shooting gallery, and Earth is not immune to the threat of asteroids. The possibility of another catastrophic impact is a sobering reality, urging us to remain vigilant and prepared. You might think, that was millions of years ago. What are the chances of another asteroid hitting us? Here's the thing, space is vast, but it's not empty. Millions of asteroids zip around our solar system. Most are harmless, but some are large enough to cause serious damage if they hit Earth. We're not talking about extinction-level events every day, but even smaller asteroids can cause significant damage. Remember the Chelyabinsk meteor in 2013? That was a relatively small asteroid, only about 60 feet across. It exploded over Russia, releasing energy equivalent to about 30 Hiroshima bombs. The shockwave shattered windows, injured over 1,000 people, and caused millions of dollars in damage. And that was a small one. Scientists around the world are constantly monitoring the skies for potential threats. Advanced technology helps us detect and track these space rocks. With computer simulations and data analysis, we can predict their paths and potential impact zones. There are even missions designed to deflect or destroy asteroids before they reach Earth. These efforts are crucial in preventing future disasters. History has shown us the devastating effects of asteroid impacts. It's a global effort, requiring cooperation and collaboration from all nations. As we advance our technology and understanding, we become better equipped to protect our planet. Ensuring the safety of Earth for future generations is a responsibility we all share. So while the threat of asteroids is real, our vigilance and innovation give us hope. Together, we can keep our planet safe from these cosmic threats. We categorize asteroids by their potential danger. Small ones, like Chelyabinsk, can cause local damage. Larger asteroids, a few hundred feet across, could wipe out a city. Then there are the planet killers, asteroids miles in diameter. These are the ones that keep astronomers up at night. A planet killer impact is a very rare event, but the consequences are unimaginable. Global devastation. Climate change on a scale never seen before. The collapse of civilization as we know it. The good news, we're getting better at finding these threats. We have a global network of telescopes scanning the skies looking for any object that might pose a threat to Earth. These telescopes are our early warning system. They're constantly searching for new asteroids, tracking their orbits, and calculating the probability of an impact. One of the most important tools in our arsenal is the Pan-STARRS telescope in Hawaii. Pan-STARRS scans the entire sky several times each month looking for anything that moves or changes brightness. It's incredibly effective at finding new asteroids, including those that might be on a collision course with Earth. Section 5 Space Sentinel's cutting-edge detection tech, but we're not stopping there. We're developing even more advanced technologies to improve our asteroid detection capabilities. NASA's NEO Surveyor mission, set to launch later this decade, will be a space telescope dedicated to finding and characterizing potentially hazardous asteroids. Unlike ground-based telescopes, NEO Surveyor will be able to see asteroids that are difficult to spot from Earth, including those that are hidden by the sun's glare. It will also be able to determine an asteroid's size, shape, and composition, giving us valuable information about its potential threat. Section 6. Cosmic Billiards, deflecting the threat. Finding a potentially hazardous asteroid is only the first step. The next, and arguably more challenging step, is figuring out how to prevent an impact. Luckily, we have several options on the table, each with its own set of advantages and challenges. The key is to act early. The more time we have, the better our chances of successfully deflecting an asteroid. One promising approach is called the kinetic impactor. It's exactly what it sounds like, ramming a spacecraft into an asteroid at high speed to change its trajectory. Seems like something out of a science fiction movie, right? But it's a viable option, and we've already tested the technology. Section 7. Nudging asteroids, gravity tractors and solar sails. If a kinetic impactor is like a game of cosmic billiards, then a gravity tractor is like a gentle nudge from a cosmic tow truck. The idea is to use the gravitational pull of a spacecraft to slowly tug an asteroid off course. It's a slow and delicate process, requiring years, if not decades, of lead time. But it's a very precise method, and it doesn't require any explosive force. Another intriguing possibility is to use solar sails. These are large, reflective sails that harness the pressure of sunlight to generate thrust. By attaching a solar sail to an asteroid, we could slowly but surely alter its trajectory over time. Section 8. Last resort, the nuclear option. Now let's talk about the elephant in the room, nuclear weapons. It's the option everyone thinks of, but it's also the most controversial. Using nuclear weapons to deflect an asteroid is a complex and potentially dangerous undertaking. There's the risk of creating radioactive debris that could rain down on Earth. There's also the ethical dilemma of using weapons of mass destruction in space. However, in a worst-case scenario, a carefully planned and executed nuclear detonation might be our only hope of preventing a catastrophic impact. Section 9. United. We stand. Global cooperation for planetary defense. Asteroid defense is not a one-country problem, it's a global challenge that requires international cooperation. No single nation has all the resources or expertise to tackle this threat alone. We need to work together, share information, and coordinate our efforts to ensure the safety of our planet. The United Nations has recognized the importance of planetary defense and has established the International Asteroid Warning Network, or IADN, and the Space Mission Planning Advisory Group known as SMPAG. These groups bring together experts from around the world to develop strategies for detecting, tracking, and deflecting potentially hazardous asteroids. Section 10. Looking ahead, the future of asteroid defense. As technology continues to advance, we can expect even more innovative solutions for asteroid defense in the future. We might see swarms of small spacecraft working together to deflect an asteroid, or powerful lasers used to vaporize its surface and alter its trajectory. We might even develop the capability to capture and mine asteroids, turning a potential threat into a valuable resource. The field of asteroid defense is still in its early stages, but it's a rapidly developing field with incredible potential to safeguard our future. Section 11. Our cosmic duty protecting our pale blue dot. We live on a fragile planet, a tiny oasis of life in the vastness of space. Our Earth, with its delicate atmosphere and unique ecosystems, is a rare gem in the cosmos. It is our only home, and it is our responsibility to safeguard it. The threat of asteroid impacts is a stark reminder of our vulnerability, but it's also a call to action. These celestial objects traveling at incredible speeds have the potential to cause catastrophic damage. Yet they also present an opportunity for us to unite and innovate. We have the knowledge, the technology, and the responsibility to protect our planet from this cosmic threat. Our advancements in space technology have given us the tools to detect and track these potential dangers. But having the tools is not enough. We must also have the will to use them effectively. We need to support research and development of asteroid detection and deflection technologies. Investing in these areas is crucial for our long-term survival. By improving our detection capabilities, we can identify threats early and take necessary actions to mitigate them. We need to educate ourselves and others about the importance of planetary defense. Awareness and education are key components in building a resilient society. Schools, universities, and public forums should emphasize the significance of protecting our planet from extraterrestrial threats, and we need to work together as a global community to ensure the safety and prosperity of future generations. International collaboration is essential. No single nation can tackle this challenge alone. By pooling our resources and expertise, we can develop comprehensive strategies to defend our planet. The dinosaurs didn't have a space program, but we do. Their extinction serves as a powerful reminder of the potential consequences of ignoring cosmic threats. We have the advantage of advanced technology and scientific knowledge, and we must use it to prevent a similar fate. Let's use it wisely to protect our planet, our home, our pale blue dot. By taking proactive measures today, we can ensure a safer and more secure future for all inhabitants of Earth. Our actions now will determine the legacy we leave for generations to come.